Welcome to The Explainer. Today, we are going to cut through all the noise and really demystify one of the most talked about fields out there, data science. We're going to go from those confusing buzzwords you hear everywhere to the actual building blocks so you can understand what it's really all about. You hear these terms thrown around constantly, right? Artificial intelligence, machine learning, data science, and a lot of the time they're used interchangeably. It's easy to get them all jumbled up, but I promise by the end of this, you'll see exactly how they fit together crystal clear. So here's our game plan. We'll start by sorting out those key terms. Then we'll dive into this really cool creative process called feature engineering. After that, we'll see it in action with a real-world house price example. And then we'll wrap up with the foundational ideas that make the whole thing tick. Okay, let's jump right into this first section. Our goal here is pretty simple. Let's bring some serious clarity to these big and often confusing ideas. First up, AI. Think of artificial intelligence as this giant, massive umbrella. Seriously, it's the whole grand ambition of making machines smart. It covers everything you can imagine, from robots and complex planning to understanding the way we talk. Okay, so under that big AI umbrella, you've got machine learning. Now, ML isn't all of AI. It's a specific and incredibly powerful part of it. It's all about algorithms that learn directly from data. They find patterns and make predictions all on their own, without a human programming in every single rule. And that, of course, brings us to data science. Now, if machine learning is the super high-performance engine, you can think of data science as the entire workshop that builds and maintains it. It's the whole process, collecting, cleaning, analyzing, and visualizing data. It provides the clean fuel and the solid foundation that ML absolutely needs to run. So let's just put it all together. The big takeaway here is this. AI is the overall goal, right? The big dream. ML is a key method we use to get there, and data science is the discipline that makes all that effective ML even possible. They're not the same thing, but they are totally deeply connected. Alright, let's move on. Now we're going to see how all this builds into what a lot of data scientists would tell you is the most important and honestly, the most creative part of the entire process. This is where the real magic happens. Feature engineering isn't just about running algorithms. It's about being clever and using your intuition. It's really the art of taking raw, kind of messy data and skillfully crafting it into powerful signals that a machine learning model can actually understand and learn from. And this quote just nails it. It really highlights why this is so critical. You could have the most advanced, most complicated algorithm in the world, but if you feed it garbage data, guess what? You're going to get garbage results. The quality of your input, your features, is often the single biggest thing that determines whether you succeed or fail. Okay, theory is great and all, but let's make this way more concrete. We're going to walk through a classic example that you can probably relate to, predicting the price of a house. So imagine this is the raw data we get from some real estate website. It's got the basics, number of bedrooms, square footage, the year it was built, and the date it was sold. This is our starting point, our raw material. And it's useful, for sure, but it's hiding some much more powerful information. And here's that feature engineering in action. Instead of just using the year the house was built, what if we calculate its actual age? That feels more useful, right? And instead of a specific sale date, what if we pull out the season it was sold in, since we know housing markets can be seasonal? Better yet, what if we combine the total area and the number of bedrooms to create a totally new feature, the average room size? Now, check out the result. This new table is so much more insightful for a machine to learn from. Age is a way more direct signal of a home's condition than just its build year. Season of sale captures market trends. And average room size, well, that tells us something about the layout and feel of the house. See what we did? We transformed basic facts into a much, much richer story. So we've seen the what and the why. Now, let's quickly look at some of the foundational statistical concepts, the real building blocks that data scientists use every single day to start making sense of all this data. Okay, so at its most basic level, data really just comes in two main flavors. You've got numerical data, which is anything you can measure, like the price of a house, and then you have categorical data, which is all about labels or groups, like the city a house is in. Just knowing which type you're dealing with is the first step, because it determines what tools you can use. First up, the mean. You almost definitely know this one. It's just the average. It's a super quick and simple way to find the center of a bunch of numbers, and it gives us our first guess at what's typical in our data. But the mean has one big weakness. It can get totally thrown off by outliers, extremely high or low values. And that's where the median is so useful. By finding the exact middle value in a sorted list, it often gives us a much more realistic picture of what's actually typical. And here is a perfect real-world example of why that matters so much. The average or mean US household income is pulled way, way up by a pretty small number of incredibly wealthy people. The median, on the other hand, tells us what the household right in the middle actually earns. It's a huge difference and a much more honest picture. And finally, once we know the center of our data, we also need to know how spread out everything is. For instance, are all the house prices in a neighborhood packed tightly around the average, or are they all over the place? That's what variance tells us. It gives us a single number to measure how spread out or dispersed our data is. So when you boil it all down, the big takeaway today is that data science isn't really just about crunching numbers or building these super complex models. At its heart, it's about transformation. It's about taking raw, seemingly random information and using creativity and some foundational principles to find the hidden patterns, the stories that live inside. Which leaves just one question, really. What story is your data just waiting to tell?